In the last episode, we looked at natural ecosystems and how they functioned. We ended at a point in history when humans were making the transition from foraging to farming as their food production system. In this episode, we'll look at the development of human ecosystems and the impact that those systems have on natural ecosystems and the environment. Human ecosystems are made up of populations of chosen or selected species within a particular physical environment. The whole thing is controlled by a single species, humans. A human ecosystem is similar to a natural ecosystem in some ways. They're both open systems which use energy and matter from the environment to produce food in the form of populations of living organisms. And they both make a variety of habitats based on the species which are present and their physical surroundings. But there are a number of significant differences. A natural ecosystem, or N system for short, is both complicated and complex, whereas a human ecosystem, or H system for short, is just complicated. The N system is complex because it's adaptive, self-organizing, and has emergent properties, all of which result from the interaction of the various species within their surroundings. The H system is not complex because it's adapted, organized, and designed by humans, not by the interaction of the different species. As a result, N systems are inherently stable and sustainable, whereas H systems are not. They require constant intervention by humans to maintain their stability and sustainability. There are also differences as food production systems. Foraging is an immediate return system. The food gathered today is eaten today or tomorrow at the latest. In farming, there's a significant time delay between the start of the process and the end. It takes a long time to plant and grow crops and breed animals before they're ready to eat. In a foraging system, the food is distributed throughout a wide area and is varied in both type and availability, whereas in farming, the food is concentrated in a small space and is nowhere near as varied or unpredictable. Just like natural ecosystems, human ecosystems come in a wide variety of shapes and sizes. The result is an equally wide variety of man-made habitats. There are all sorts of farms: dairy, livestock, arable, poultry, fish. There are plantations, orchards, ranches, estates, paddy fields, small holdings and allotments. All man-made habitats based on man-made human ecosystems. Now that we know what a human ecosystem is, what it looks like and how it fits in, we can begin to model how it functions. We know from the episode on natural ecosystems that foraging has balancing feedback loops, which make the ecosystem stable and sustainable. But what of farming? Agriculture is a man-made ecosystem which serves the needs of a human reproduction system. There's a reinforcing feedback loop, which means that the human population will either increase or decrease depending on the rate at which food grows. As with natural ecosystems, we can quantify the behaviour of a human ecosystem over time. If we simulate the effect on human population with a growth rate just sufficient to feed the population, then the population will remain stable. A very small deviation away from that growth rate will result in a growing or declining population. Up until now, we've been working on the assumption that every individual in a population has been involved directly in either foraging or farming, but that's clearly not the case. There have always been plenty of other activities: caring, education, making things, and on good days, leisure. Of those, making things is the one that has the most impact on food production. Foragers spent much of their time making tools and weapons, which greatly increased foraging productivity. As a result, the population had an increasing average lifespan. But the increasing lifespan would have no effect on the stability of a natural ecosystem. By adding diversity of activity in the form of manufacturing or the production of goods to the farming model, the system becomes more complicated. There are now two ways to increase food production. There can be more people farming and producing more food, or there can be more people making new tools which improve the way farming is done to increase the productivity that way. Either way, food production can be increased. To quantify the effects of both growth rate and diversity on the farming system, we need a new computer model. When the global climate changed and the world began to warm up at the onset of the Holocene, some fertile areas of the world became wetter and warmer. Natural growth rates increased sufficiently for farming to be a viable alternative to foraging, and the transition to modern society began. If we reflect the change in growth rate in our model, we can see the effect on human population. Much later, the Industrial Revolution greatly increased both diversity and food production. Large numbers of people left the land and went to work in the factories, a significant increase in diversity. But mechanization, the output from the Industrial Revolution, more than compensated for the loss of people directly working on farming on the land. By reflecting the change in diversity at the time of the Industrial Revolution in the model, we can see the impact that it had on human population. To see what happened more clearly as a result of the Industrial Revolution, we can take a closer look at the last 500 years. We can see here the dramatic increase in population and the equally dramatic change in diversity, with the majority of the population now engaged in non-farming activities. Whilst not perfect, this model is a reasonably accurate representation of population change as far as we can know. Up until now, we've modelled ecosystems on the basis that the environment is unlimited and invariable, but we know that that cannot be true. If we model the human ecosystem and its environment, we get a very different picture. We start with the basic human ecosystem, a population which produces its own food. The bigger the population, the more production there is. Production also includes all manner of goods, and if production rises, the quality of life increases as well as the quantity. Let's see what effect the human ecosystem has on the natural ecosystems which are now part of the human ecosystem's environment as the biosphere. By cutting down forests, burning grass, overfishing and spraying insecticides which kill pollinators, the larger the human population, the greater the negative impact on other species, which in turn has a negative impact on farming production. The overuse of land for farming turns it into desert, and the more farming there is, the more deserts there are. The more deserts, the less fertile land there is for farming, and production drops. What about the effect of production of goods on the hydrosphere, geosphere and atmosphere, the other parts of the environment? The matter which is exchanged between the human ecosystem and the environment goes way beyond the elements necessary for life and includes the majority of non-renewable resources on the planet coming in and huge volumes of waste material going out. The more production there is, the more non-renewable resources are consumed, and the harder they become to find and extract, which reduces production. And the more production there is, the more waste matter is returned to the environment as pollution. Increasing pollution reduces life expectancy, has a negative impact on quality of life, and reduces producer populations in natural ecosystems, which then reduces food production. We know enough about system dynamics now to know that all the balancing loops from the environment will increasingly act against the reinforcing loop of the production systems. At some point, both the quantity and quality of life must decline. The only questions are when and how far will they fall before the system stabilizes, if it ever does. To quantify the impact of human ecosystems on natural ecosystems and the environment, we would need to include a wide range of social systems in the model. For example, manufacturing, trade, extraction, and economies. In order to simulate all of that, it's a major exercise which could only be done with the development of high-speed digital computers. In the 1970s, a group called the Club of Rome did exactly that, and they published their model under the title World 3. This picture shows just one level of the 12 levels which make up the complete World 3 model in Vensim. This is the model for agricultural productivity, and if you pause the video and look closely, you will find quite a number of the pieces that have appeared in our models as we've gone through this episode. So far we've only used models to look at the past up to the present, but if you can show that the model works, it accurately represents historical data, then you can also use it to predict the future. That's exactly what the Group of Rome did with the World 3 model. They showed what the probable outcomes would be if humanity continued to act as it was then, with no change in its behaviour. What this shows is continuing improvement in the quality and quantity of life up to the middle of the 21st century. At the same time, renewable resources were depleting fast and pollution would continue to increase. Then everything would change. Productivity would drop dramatically, with reducing industrial output and food per person. Following from that, population would drop at an alarming rate, all of which would mean that the quality of life for billions of people would become unbearable. It was this model which finally demonstrated the impact that human behaviour was having on the world and foretold our future. It looks bad, but it's worth remembering that no models are true, but some are useful. This model, however, proved to be reasonably accurate, but it was also useful in that it raised awareness and began to change our behaviour. As it is now, it's clear that human ecosystems and production systems are neither stable nor sustainable. In the next episode, we'll look at what needs to be done and how we can do it and at the same time avoid repeating the mistakes of the past.